All right, here we are learning about something called the volume of shapes. But volume means how much space is inside. But before I tell you anything detailed about it, let's just look at this and think for a minute, okay? Like we got a picture up here, and I want to know if you feel comfortable knowing what that is. Like, what is this shape? So think about it, think about it, think about it. You thought about it. Hopefully you came up with the name cone. That right there is a cone. It's like got a circle as the base, and then it kind of goes up to the point, and it's a cone, like an ice cream cone or a cone hat somebody might wear on their head. So to move that out of the way, and let's say, well, what about this? What do we call that particular shape? Okay, thinking. And we would call that particular shape a cylinder. It's got a circle on this side, and then a circle on that side, and then all that space connected in between. And you might think of a soda can or like a food can, like a soup can. Probably in your pantry or in wherever you keep your food, there's probably some things that look like that. It's called a cylinder. Okay, now check out that thing. What would you call that thing? All right. Now you might be thinking like basketball or volleyball or something like that, but that's a type of sport ball. This shape has a particular name, and that name is a sphere. So there are a lot of things that are spherically shaped, which is why we thought of other things like a basketball or a volleyball or a soccer ball. Like a little BB, that thing looks like a little silver BB to me, but all those things that are round in 3 dimensions, we call them spheres, like the Earth is a sphere. Mostly, it kind of bends at one point. Okay, now then underneath here, yep. If we look at this circle, and I said, what would you call this line that goes halfway across, this white line that goes halfway across? That's the next question. Thinking about that, you're thinking about that.
Pac-Man?
Come up with, Pac-Man is correct, or, as we sometimes say, the radius, this word right here, the radius is half of the distance across a circle. And then maybe we'd move that out of the way and take this blocker away, and then we'd say, well, what if there's a line all the way across the circle, like right there? What would we call that? And hopefully you would land at the word diameter. Okay, now here's something you might need to know. You've learned about radius and diameter before. You've heard it. People have tried to give you little ways to remember it. That's great. You may have forgotten. Like each time you run into a circle and you got to do the distance thing, you might not feel solid in it. So here's my advice to you. Take the word radius, take the word diameter, and just write them out. Like write radius and write diameter. If those are the two choices, you're not sure which one's which, just write them out. And then think to yourself, which one of these is longer, the diameter or the radius? Well, check it out. Diameter is a longer word, and the diameter is the longer distance. It's all the way across, whereas the radius is only half of the way across. Okay? All right. So if you get lost, you need to be writing those words down. That will help you out. 2 other things which I don't really have a picture for. One is the word volume. Volume means how much space is inside something. So I got my big trash can here. How much space is inside this trash can? How much water? How much, how many gumballs? How many whatever could this thing hold? That is a question of volume. The last word is the word dimensions. And dimensions are the measurements of a shape or an item. So it may be 5 feet tall. That's one of its dimensions. It may be 4 feet across the diameter. That's another dimension. So dimensions are the numbers that we use to figure out other bits of information regarding shapes. Okay, there's your review on shapes. Now I'm going to turn it over to Dr. Walton for an explanation of circular acuity.
All right, so just as Mr. Campbell just explained, when we have a line that is being drawn through our circle but only halfway, this is going to be the shorter of the 2 words called the radius. And radius, just like we had dimensions that Mr. Campbell just mentioned, we have given values for this. And then we also see a formula right here. A equals pi r squared. That capital A stands for area, and maybe this is something that you remember. Right here we have area. So this is a formula that is on your formula chart that you'll be able to use on the STAR test. And the area of a circle is pi r squared. And so in order to solve for the area, we need to know our missing value, which is this r. Because we know pi, we know is 3.14. We know this is a number being squared. So we're going to look at our radius given here as 3 inches. So what we can do is take our 3 inches radius and substitute that into our formula to give us A equals, we still have pi times 3 squared. So now we know 3 squared, so we can simplify this and have, depending on whether we're using 3.14 or pi, you'll be able to use a calculator either way. So if I kept it as pi times 3 squared, which is 9, and then in your handy dandy calculator, you could use, I would grab the dead one.
Here, use the screen one.
Oh, okay. Is it here? All right. So sometimes they'll tell you whether to use pi, the pi button, which can be found at second, and then the caret button. So we have pi here. So we could do pi times 3 squared and get our answer. Or sometimes they'll say to use 3.14 as pi, so we would do 3.14 times 3 squared. And if you notice, we have a lot more decimals here because pi is an irrational number, so the decimals keep going on and on. So we notice that this is a rounded version of this same number. So that will take us for the area. And the next one we're going to look at, so this time, so we still have our area as pi r squared, but the number that they give us here is 10. But this, we need the radius, but what they gave us was the diameter. So if the diameter is twice the length of the radius, we know we can take our 10 and divide it by 2, so our radius is going to be 5 inches, and then we can do our same substitution and go area equals pi times 5 squared. So a lot of times people will go ahead and just use that 10, but obviously 10 squared and 5 squared are very different. So I'm going to go back to my calculator, and I'm going to use 3.14 times 5 squared, and we'll get 78.5 as our answer. So our area is 78.5 inches, but once we solve for area, it becomes inches squared. So it's the same concept, except on this one we just had to divide our diameter in half. And Mr. Campbell.
Whoop-oo. All right, so how do we put it all together and make a volume of a cylinder? Here's what we do. We look at this and we go, well, what does this have to do with what Ms. Walton just taught me about that circle and all that stuff? Well, here's the deal. See, the bottom of a cylinder is a circle. And in order to find the volume, to find out how much space is inside it, you actually have to know how big this right here is. And it's a circle. And so like we just did some work with a circle. We're going to take that learning and use it right here. And I'm going to tell you to do something that we're always going to do with shapes. And here it is. We're going to shade the base. That means we're going to look at the bottom, what the shape is sitting on. And we're going to kind of mark it off and say, hey, I'm looking at that thing right there. That's the first thing I'm going to look at. Because here's the deal. In order to find the volume, we have to know how much area is in that space. Here's how you do it. First of all, you have a formula. The formula is volume equals, and by the way, you're going to get something, if you're in person, then you're going to end up using something like this a lot. It's a formula chart. If you're not in person, there'll be a PDF of it online. So like this has all the formulas you need. So you don't have to memorize this. You just have to know that it's on the formula chart. All right. The volume of a cylinder equals a big B times a little h. Now, that little h you probably may just kind of figure out it means the height of something, like up and down like this. That big B, you might feel like that means one thing, but I don't even want to let you guess right now. I just want to say that big B means the area of the base. Okay, the area of the base. It's not a length of something, it's an area of something.
At this time, please stand for the pledges. I
pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Now the Texas Pledge.
Under the Texas flag,
I
pledge allegiance to thee, Texas, one state, under God, one and indivisible.
Please hold for a moment of silence. Thank you.
So to find the area of the base, we have to find the area of that circle. Well, we just learned how to do that. We have to do pi r squared, which means that b equals pi r squared. So wherever that b is right there, instead of writing b, we could throw in this, because in this shape, that's how you find the area of the base. Okay, let me back up one more thing and just remind you. When you see a big B, that means area of the base. In this particular case, the base is a circle. And to find the area of the circle, you use pi r squared. That's why we're saying b equals pi r squared. Okay, now we're going through a process. You've seen it before. It's the formula substitute solve process. Right here is the formula. Defined a couple things for you. The substitute phase is when you plug in the numbers. But where are the numbers, somebody said?
Where are the numbers, Mr. Campbell?
Great question. They're over here behind that pentagon thing. So if I tell you that the radius of this cylinder is 3 feet and the height is 10 feet, then you've got to take these numbers and put them over here where they belong. And this is where they belong. Volume equals capital B, but we're not going to write B anymore. And we're actually not just going to write one number. We're going to write pi times the radius squared. See that? Pi times the radius was 3, squared, okay? And then the other part we have to write is the height, because we already did the capital B, and the height is 10, and so that's where it lands, which means that the solution is going to be all this typed out in the calculator, which will give us 282.7 feet cubed. So here's the deal. There's a PDF on there for practice on the volume of cylinders. If you don't feel ready to go do that right now, then watch this part of the video again, especially this particular slide right here, and go slowly, and then maybe do that with the piece of paper in front of you. But everything you see on that piece of paper will be exactly like this process, with the possible exception that on some of them, instead of telling you the radius, it will tell you the diameter. And so if it tells you the radius, you're good. Plug it in and use it. If it tells you the diameter, you've got to cut it in half, and then you can use it. Good luck.